Hello, today is May 7th, 2020. My name is Rusty Rayburn. I am an instructor at Belleville West High School in Belleville, Illinois. I'm currently enrolled in a course with Professor Norman at Pittsburgh State. It is an alternative fuels course, and this is my project that I created for that course. What we have in front of us is basically a downdraft style gasifier. This gasifier actually takes a biomass such as wood, turns it into a gas that is usable to actually power a motor, or you can use it to burn for other purposes as well. What we're going to do today is we are actually going to discuss how the operation of this works, who the original design came from that I built, and the basic operation. We'll also get into the parts and equipment that was used into building this downdraft gasifier. And let's start off by talking about the design. I did not design this entire gasifier. This is based off of a design by Flash 001 USA on YouTube. He spent about 5 to 7 years perfecting his for a 5.5 horsepower motor. I built mine a little bit different. Number one, I was going to run it on a 12.5 horsepower motor, so that I had to design a few things a little bit different. We're also in the coronavirus lockdown, so some of the parts and things that he used, I was not available to get. So mine is a little bit different of a system. The main heart of this gasifier is basically designed on his measurements, his calculations, and things of that matter. Today what we'll be burning in this is going to be a wood pellet, a hardwood pellet. This downdraft gasifier will actually pull in air from the top, pulls air through the biomass, wood pellets in this situation. We'll pull it down. There's an air jet in there that allows air to be at the bottom of that wood, and it will actually catch that wood on fire and burn it from underneath. Okay. What this does, it will burn it at approximately 900 degrees, somewhere around there, we hope, to actually create a gas that is usable. Syngas or wood gas is basically what it's known as. This technology is nothing new. It has been around since the 1800s. Okay, in World War II, there were many cars in Europe due to the oil shortage that had these mounted on them and allowed them to actually use this to run their vehicles with. The Germans even used it to power some tanks as well. So we'll go ahead and get into some of the different parts in depth, and then towards the end of the video we will fire this up in real time. First part of the gasifier that we're going to talk about today is what I would consider the heart of the gasifier. This is going to be where the pyrolysis and the wood hopper, air intake, ignition port, and shaker are all going to be housed. We're going to go ahead and start with our lid here. This lid I designed kind of out of necessity, instead of exactly what I would like to have. This took me a little bit less time. Once I got it designed, I wasn't too happy with it. It didn't fit very well, but I will probably redesign this lid and actually weld it to the bottom here and create a piece up top where I can actually open and close this lid. Right now what you have to do, you actually have to pull it up off of there. I wanted a slip fit. This slip fit turned out to be a little bit of a issue with sealing, and actually once it started getting hot and things like that, pulling it off of there quickly and things of that matter. So I'm going to go ahead and redesign this and allow this to basically cut a hole in the top here and allow this to have a sealable lid that can easily be opened to check the amount of wood or biomass that is in the hopper, and refill, obviously. So we'll go ahead and take that off here real quick and take a look inside. Inside our wood hopper, you can actually see at the bottom down here is our fire cone. Yeah, it does have pellets in it right now. It did run. I pulled some of the other pellets out, but what we'll actually do down there, our ignition port, or our intake port, actually comes from here, goes into the barrel, and is welded. A pipe is welded in here. We've got a 90-degree angle, comes down, and then you shoot straight into the center of the fire cone. What that does for us is that allows us to direct where the air jet goes, so that once we get this biomass started, it will actually start burning that biomass and creating our wood gas. The diameter of the pipe for this is actually going to be 3/4 of an inch. Flash 001 USA runs a 5.5 horse motor. I was going to run a 12.5 horse motor on this. So with his, he only has to run a 1/2 inch diameter pipe with up to a 17 horsepower engine. He actually recommends on his videos to move up to a 3/4 inch pipe. So that's what I did. Our fire cone down here in the bottom is got a 1 inch extension on it that's straight. It goes down from a 5-inch diameter down to a 3-inch diameter. Is going to be where our ignition port is. It comes through the side of the barrel. The ignition port is made out of 1-inch pipe. The ignition port, actually, I put a 90-degree angle on here so that I wouldn't burn my fingers. I could take this plug off. Now, I found that it was just easier just to unscrew this and do my ignition that way. What we have here is basically a 1 1/4 inch threaded bung, or I guess you would call it a close connection, and then we have our 1-inch pipe here. What that does is that goes into right underneath the air jet, so we can actually start our ignition here, get that going before we open up our air jet up top. Once we get going with this, once we see that we have an ignition, we can actually close this off and start the air jet intake air jet opening. Why I did this way, I wanted to have a seal, and you can see by the tar that it is sealed, but this pipe is also removable. If I want to take this off, the lid off, and disassemble this, it's easily done. I can actually put a pipe wrench on the end of this pipe sticking out. It's threaded into a coupler. We can unthread that, take the ring off, and we can pull the entire hopper and everything off all as one unit. Now this allows this to be sealed, and I wanted to be able to have a larger diameter 90 degree ignition port, so that I could feed paper and things like that into this 90 degree. So, but I found that it's just easier just to put on a pair of welding gloves, or actually don't even need welding gloves. We do this before everything gets hot anyway, and tighten that up. So that is our ignition port, and you will see that in operation once we start. Next, we'll talk about the shaker grate. The shaker grate goes down into the bottom. It is actually underneath our fire cone here, and really a good way to get down to that right now, as it has the some wood pellets still in it. I want to leave those wood pellets in there so that we have something to get us started, as the ones towards the bottom are already biochar and they will ignite easier. Over here, our shaker grate actuator, I guess we'll call it, is going to be a design of my own. Flash 001 USA, what he actually did is he went into the side and had a pretty elaborate system with threaded rod and things like that. I went with what I felt like was a simpler system, but a pretty neat design. I used the bung that was already in the top of the barrel and drilled it out to accept a 1-inch diameter close fitting. I put that in there, welded it to the top, and then here I used a 3/8 drive 10mm socket and welded it to a rod. I found a bushing that would fit inside a 3/4 inch pipe, which is underneath this, and ran that pipe down the side, or down inside of this, welded a support in there, and then went ahead and curved that rod, and it goes into the bottom of the hopper. I did this so that this could be easily sealed, okay? And to actually make this work, you will actually take, this is just a contraption I made up really quickly. You can actually hear it moving the grate. I can feel it in my hand. You shake it, pull it off, and put the lid back on. Okay, so what that does is that knocks the ash from the bottom of the fire cone away so that we can get a good draft on this. I actually have a little 3/8 breaker bar that will be welded to a chain onto this cap, and that way it won't ever leave the barrel. Right here I actually welded a ring around our propane tank. This used to be a 100 pound propane tank, and it needed some structure to be welded to this, and also some structure to be welded to the top of this thin barrel. So what I did is, this allows the weight to actually be distributed through between the barrel and that propane tank. This is pretty heavy. It has a wheel on the bottom basically, and our fire cone is insulated with plaster of Paris and playground sand that's welded to the bottom of this propane tank. And that is pretty much that. So that's going to be our main source of our pyrolysis, and we are going to then go over to our expansion tank. When we turn this on, the blower on, it's going to actually suck the gas from this, the hot gas, I should say, from this outside of this barrel, okay, on the inside, the outside of this tank, but in the inside of this, it's going to go up through a 3-inch U-bend and then down into this 25-gallon Valvoline barrel. Okay, why did I use 3-inch? Well, it was because I had it laying around in the shop. I do exhaust work, and this 3-inch was available, so I actually had some connectors for it, welded it in, This is allowed to be able to slip out. This allows this to be able to slip out so that you can move these barrels, store them easier, and it doesn't take up a lot of room. So at our connections, you'll notice there is masking tape. Masking tape, I decided to use that to help seal it. It is a slip fit, but I wanted this thing very airtight. So what I ended up doing is putting masking tape around this for my runs. Would I leave it like this? No. What I would actually do is I do have fire caulk, and you can put that around, but around every slip fitting and anywhere that I saw that might be a potential leak, I went ahead and put tape around that. Masking tape will at least hold up to 450 degrees for a pretty long time, because I know this because I actually use it when powder coating parts at the shop. Moving on to our expansion barrel, really nothing special. Inside our expansion barrel, it is just opened up inside of there. All it does is allow that gas to expand. When that gas expands, it will actually cool down. Expanding gas will actually cool down, just like in an air conditioning system. When we come back up through here, we go into our cooling tower. Our cooling tower is made out of 2 3/8 inch fence posts. If you notice, on all the corners I actually have masking tape just to be sure. Didn't see any leaks, but might as well put the tape on there. It's cheap, easy to do. I cut 45-degree angles on the tops of the posts, I guess you would say. Welded them all the way around, every one. I put in a brace in the center just to give it a little bit more rigidity, and down at the bottom, this guy is a mason jar. What I did with this mason jar is this allows you to watch the color of your gas, and also check on your I guess you would say your quality of your tar. See if it's really sticky, really stainy, or anything like that. Each one of these posts are going to be 32 inches tall and have a 12-inch straight with a 32-inch tall leg, all except for this one. This one actually had to have an extension welded on because our filter barrel is not as tall as our expansion barrel. This jar, kind of back to this jar here, what I actually did was created a washer that was the same size as the lid. Inside of here there is actually a rubber gasket that is made out of a old inner tube, and it works good, seals it up very well. I bought this little jar. We had a couple runs with really sticky tar, but one of the runs that we did actually came out with a watery tar that wasn't stained, wouldn't stain. You can actually see on my hands here, that was from about 4 days ago. This stuff is nasty stuff. I did take a shower and I did scrub this as much as I could, and it gets stuck down in the pores of your fingers and stains very nicely. So if you ever want to some really tough wood stain, there you go. Back to the top, we come down into our filter barrel. Inside our filter barrel I have 2 3-inch diameter tubes that are teed off of this. At the bottom here we go into PVC, so I have a coupler that will fit inside of this, which is 2 1/8 outside diameter, will actually slide into this, and then it's a 2-inch outside diameter that will actually slide into with a little coaxing and a little sanding on your fitting, your PVC fitting, and then we threaded it into the top of this. You'll see all this masking tape. I didn't want to put a bunch of fire caulk on this at this point. I just wanted to get it running, check everything out. So I put the tape around there just to seal it up for now. I will go back, fire caulk it, make it better and refine it a little bit more. We're able to go into this barrel being plastic and PVC because at this point, this gas, after running through the expansion tank, through the cooling tower, coming into this is very cool. I can, when it's running, I can put my hand on it, it doesn't even burn me. And if you think about the PVC, it could have hot water running through it, and it is rated at a pretty high temperature. When this goes through the filters, they are 3-inch PVC with holes in them, and they have screen, 32-inch piece of screen, doubled over and rolled up, and inside of that the gas goes through the screens that are actually rolled up inside of there and then comes out of this side over here. When it comes up through here, we go into a hose that is actually meant for a sump pump. This hose that I have, so that it would be nice, make sure it would be nice and cool, and it was only $6 for the entire hose. I went ahead and just left it its entire length. It is a 24-foot hose. When the gas comes out of here, it feels doesn't even feel warm. It feels like air temperature. On the end of the hose, we have a blower that is full of tar. That was from the first 2 runs, and it was actually kind of spitting out tar. There will need to be some more refinements to get this going with less tar. I didn't hook it up to my engine because of the simple fact that I didn't want to put that kind of tar into my engine. I wanted to refine this till it wasn't putting out as much tar so that I could have a nice clean burn. I also have 2 pipes that I had laying around. This one, I actually stick the end of the blower. This blower is actually a 120 volt air mattress blower. I can actually put it into the end of this pipe. This slows that force of air down, and I can light it and get kind of a pretty light flame, orange with blue in the center. This one over here is more a bit more pressurized, I guess you would say, and it actually gives us about a 6 to 8 inch flame kind of shooting out like a torch. Once we get this thing fired up, you will hopefully be able to see those 2 in action. Okay, we're going to get ready to put some paper in the ignition port. If you look over by the blower, you can see that no gas is coming out at this point. You can hear it running, I'm sure, and no smoke is coming out because we have not ignited it yet. So what I'm going to actually do, roll up some of this paper, and there is a draw on this. I can feel it coming, the air being pulled through my hands. We're actually going to twist this paper up, and you'll notice the flame is sucking in when I ignite this. Once it gets going, it will actually, you'll notice the flame is being sucked into that. Okay, if you look over, we'll actually see just that fast we've already got smoke coming out of this thing. And I'm going to go ahead and put the lid back on this. As I do that, I'm also going to open the lid on our air intake port. Sounds like our blower is having a time of its life. If you notice, you can actually see the gas inside of this. You should see the gas inside of this. And our little trooper of a mattress blower ain't giving up its ghost. Okay, we've got our gas coming out pretty well. It's probably only been running maybe 2 or 3 minutes, maybe 4 minutes. But you can actually see that it can actually ignite already. Whenever I ignite this, it's actually got a sustainable flame right now. It's burning very clear. You can see that there is no more smoke coming out of this except for what's coming out of this pipe that's got some holes in it. There, the flame just went out, so I'm sure with the right air-fuel mixture, this will hold a continuous flame. Right there, we've got our flame. It's burning pretty nice. It's burning some grass off the end of the pipe right now, but that's just showing that. But you can actually see that it does have a nice flame coming out of it.